Let's work with vectors. We want to find the magnitude and direction angle for the vector with components 3, -2. A good way to start a problem like this is to go ahead and sketch the vector. In an xy coordinate system, it extends 3 in the x direction, -2 in the y direction. So there's the terminal point of the vector, and there's the vector u. To find the magnitude of vector u, what we find is the square root of the sum of the squares of the components, which is the square root of 9 plus 4, or the square root of 13. The magnitude of the vector is the square root of 13. To get the direction angle, I'll use, to find theta, the inverse tangent of the second coordinate divided by the first coordinate, or the y over x. And if you find this on a calculator, you'll see that it comes out to -33.7 degrees, again with the help of a calculator in degree mode. Now -33.7 degrees is this angle, which is the reference angle for the positive direction angle for the vector. So to find the actual direction angle, I'll take 360 and subtract 33.7 degrees. And if I do that subtraction, it comes out to 326.3 degrees, which is a direction angle for the vector. Well, it's possible to do all of that with the help of a calculator. Let's see some options that you might use. So we'll go to our calculator, turn it on, choose angle, pushing second angle, and the first option we're going to use will allow us to find the magnitude of the vector. It's this r to polar r. If we enter on that, inside the parentheses, we put the components of the vector separated by a comma. The comma is the button above the 7 on your calculator. If I push that, I get a decimal. Now I want to see if that matches what I found, which was the square root of 13. So I'm going to go ahead and find the square root of 13. And you can see that the square root of 13 is actually the magnitude of that vector, or the calculator checks what we found by hand. Now going back to angle, second angle, in this menu, let's choose option 6. And again, we want to put in the components of the vector. And we see we get that -33.69. Now that was the reference angle, and we want to subtract 33.7 approximately from 360. What we can do here is we can do 360 plus our answer, because it is a negative number, and that confirms the 326.3. Let's find the components of a vector. We've got vector W shown in the figure. It has magnitude 25.0 and direction angle 41.7 degrees, as indicated. I want to find the horizontal and vertical components. Notice that component A is adjacent to the angle, and 25 could be considered the hypotenuse of a right triangle. Component B is opposite the angle 41.7 degrees. So let's take that information and find component A by finding 25 times the cosine of 41.7 degrees. And with the help of a calculator, you'll see that that comes out to approximately 18.7 units. Component B, because B was opposite the angle, is going to be 25 sine 41.7 degrees. And again, with the help of a calculator, component B is 16.6 units. Let's write some vectors in component form. We want to write each vector in the figure in the form AB. We see 3 vectors. There's the vector U, which has magnitude 5 and forms an angle of 60 degrees with the positive x-axis. We have vector V, which has magnitude 2 and forms an angle of 180 degrees with the positive x-axis. Vector W has magnitude 6 and forms an angle of 280 degrees with the positive x-axis. So we want to write each of those in component form, and let's start with vector U. Vector U has magnitude 5, and the first component of it will be 5 cosine 60. The second component, sine 60 degrees. And if we simplify, That's going to be 5 times the cosine 60, which is 1/2. 5 times the sine of 60, which is the square root of 3 over 2. And so vector u is 5 over 2, 5 square roots of 3 over 2. Now you have to look back at the picture to get an idea about vector v. Vector v, if you look back, had magnitude 2, and the angle it formed with the positive x-axis was 180 degrees. So cosine 180 degrees and 2 sine 180 degrees for vector v. Now the cosine of 180 is negative 1. Negative 1 times 2 is negative 2. The sine of 180 is 0. 0 times 2 is 0. And that's the component form of vector v. Now let's find the components of vector w. Remember that w had magnitude 6 and formed an angle of 280 degrees with the positive x-axis. So its components are 6 cosine 280, 6 sine 280 degrees. And if we use a calculator to get values, 6 times the cosine of 280 is 1.0419. 6 times the sine of 280 is negative 5.9088. Let's work an application problem. Two forces of 15 and 22 newtons act on a point in the plane. A newton is a unit of force that equals 0.225 pounds. If the angle between the forces is 100 degrees, find the magnitude of the resultant force. With a problem like this, it's a good idea to draw a picture of what's going on. And so I've done that. Here's the point P in the plane on which the forces are acting. One force is 15 newtons, one force is 22 newtons, and the angle between them is 100 degrees. And vector PR is the resultant vector, or the force, or the vector that represents the resultant. I want its magnitude. In order to work with it, I'm going to use the law of cosines in this triangle, or in this parallelogram, or for this parallelogram. Note that this side is also 22 if that side's 22, they're parallel. And this side's 15 if that side's 15, they're parallel. And I do have a parallelogram, I mentioned that. Adjacent angles in a parallelogram are supplementary, which means this angle is 80 degrees. Now looking at this upper triangle, PQR, or PRQ, I'm looking for the magnitude of PR, which is the magnitude of the resultant force. According to the law of cosines, the magnitude of PR squared is going to be 15 squared plus 22 squared minus 2 times 15 times 22 times the cosine of 80 degrees, which is the angle between them. Now I'm looking for PR, so I need to calculate this value. This value, if you use a calculator, is about 594, so I should say approximately, which means the magnitude of PR itself, which is the magnitude of the resultant force, is about 24, and the units are in newtons.
Let vector u equal negative 2, 1, and vector v equal 4, 3. Find and illustrate vector u plus vector v. And here we have vector u, and we have vector v. First, we'll find the sum algebraically. So u plus v would be equal to negative 2, 1 plus 4, 3. And then we add the x components, or the first components. So we would have the vector negative 2 plus 4, comma. Now add the second components, 1 plus 3. And simplify that one more step, and we'd find that the sum is equal to the vector 2, 4. And so when we illustrate that, let me grab my red pen and draw the vector 2 comma 4, 2 comma 4. And so that sum of the two individual vectors would be the vector in red, which would represent u plus v. Let's look at another example in which we find vectors. Let u equal the vector negative 2 comma 1 and vector v equal 4 comma 3. We want to find and then illustrate negative 2 times vector u. So, algebraically, negative 2 times vector u would be equal to simply negative 2 times the vector negative 2 comma 1. We simply multiply the scalar times each of the components. So we would have the vector negative 2 times negative 2, comma, negative 2 times 1. Simplifying each of those, negative 2 times negative 2 is positive 4. Negative 2 times 1 is negative 2. So the vector negative 2u is equal to the vector 4 comma negative 2. So to illustrate that, we go to the point 4 comma negative 2, which is here. And then we draw a line to that vector. That represents negative 2u, or we also can write the vector like this, 4 comma negative 2. Let's work one more example. Let u equals the vector negative 2 comma 1 and vector v equals 4 comma 3. Find and illustrate 3u minus 2v. So in this case, 3u minus 2v would be equal to multiplying 3 times vector u and then subtracting 2 times vector v. So this would then be equal to, we multiply 3 to each of the components of the first vector. So 3 times negative 2 would be negative 6. 3 times 1 is 3. And then we subtract from that the vector that we get by multiplying 2 times the 4, which is 8, and 2 times the 3, which is 6. Then we subtract the two vectors by subtracting the corresponding components. So the first component, so we would have negative 6 minus 8, comma, 3 minus 6. Simplifying one more step, we find that this would be equal to the vector negative 14, comma, negative 3. So now let's take a look at illustrating this difference. So here I've drawn the original vectors u and v. Let's draw 3u. 3u, of course, just means a vector that goes in the same direction as u, but is 3 times as long. So negative 6 here, comma 3 there. So vector 3u would be the blue one. Then for 2v, that would be a vector twice as long in the same direction as v. So it brings us to 8, 6. So this is the vector 2v. So 8, 6. And this one for 3u was negative 6, 3. Now, the vector that's represented by subtracting 2v, or in other words, negative 2v, would be the vector that would go down to negative 8, comma, negative 6. So that would be this vector. Let me draw that in dashed. But again, notice it's the same length as 2v, but going in the opposite direction, negative 2v. And then finally, to illustrate that difference of the 3u minus 2v, we have the vector negative 14, negative 3. So it would be the vector coming from the origin going to the point negative 14 comma negative 3. So that's the vector negative 14, negative 3, and it's representative of 3u minus 2v.
Let's find some dot products. First, we want to find the dot product of the vector 2, 3 with the vector 4, negative 1. To find this dot product, what we do is we find 2 times 4 and add that to 3 times negative 1, which is going to be 8 plus negative 3, or minus 3, which is the number 5. 5 is the answer. 5 is the dot product. It's important every time you find a dot product to realize that your answer is a scalar, not a vector. Let's try another. Let's find this dot product. To find this dot product, we're going to take 6 times negative 2 plus 4 times 3. Simplifying, that's negative 12 plus 12. Summing those, I get 0. The number 0 is the dot product of these vectors. You'll find when you work with angles that that means these two vectors are perpendicular to each other.
Find the angle theta between the two vectors, vector u, 3, 4, vector v, 2, 1. So we'll use the formula that cosine of the angle between two vectors, so cosine of theta, is equal to the dot product u times v over the norm of u times the norm of v. Substituting in the values, for u, we have, of course, vector 3, 4, and for vector v, 2, 1. So we have 3 times the 2 plus 4 times the 1, which gives us the dot product u dot v. For the norm of vector u, we use the individual components, and that's equal to the square root of 3 squared, which is 9, plus 4 squared, which is 16. Then that's multiplied times the square root of, for vector v, 2 squared, which is 4, plus 1 squared, which is 1. Simplifying that, it's equal to 10 on the top, 6 plus 4. And in the denominator, it turns out this is the square root of 25, which is 5, times the square root of 5, 4 plus 1. Of course, we use our calculator to evaluate this, and it's approximately equal to 0.8944279191. And then this is the cosine of theta. So theta will be approximately equal to the inverse cosine of the 0.8944279191, and that means it's approximately equal to 26.57 degrees. Let's look at another example in which we find the angle between two vectors. Find the angle theta between the two vectors. Vector u is 2, negative 6, and vector v is 6, 2. So we use our formula that the cosine of the angle between two vectors, so the cosine of theta, is equal to the dot product u dot v divided by the norm of vector u times the norm of vector v. So for the dot product, 2 times 6 plus negative 6 times 2 divided by, for the norm of u, it's the square root of 2 squared, which is 4, plus the negative 6 squared, which is 36, times the norm of vector v, 6 squared, which is 36, plus 2 squared, which is 4. And simplifying this, we have that it's equal to, in the numerator, 2 times 6 is 12. Negative 6 times positive 2 is negative 12, so it's 12 minus 12 in the numerator. Well, in a sense, we can stop there, but let me simplify the denominator, and of course you'll see in a moment why we can stop there, but this would be the square root of 40 times the square root of 40. Square root of 40 times square root of 40. Notice that in the numerator, 12 minus 12 is 0. The denominator, square root of 40 times square root of 40 is 40, but it still doesn't matter because 0 divided by 40 is 0. And so we have the cosine of angle theta is equal to 0. And that means theta is the cosine inverse of 0. That is to say, the angle whose cosine is 0, and that's 90 degrees.